So last time we stop at this example. So we do complete a square. So just quick recap. What do we need to complete a square? Because on the previous page, which I didn't bring out, we have this. If we have a square of something equal to, let's say m, then we say a equal to plus or minus square root of m. So that is the plus or minus square root will cancel a square. I'm not sure if you have space here. I'm sorry. I remember we wrote something different here. That is plus or minus square root undo get rid of the square. We use plus or minus square root. Let's keep that in mind. Okay. And now, how do we? So if we have the square, we can get rid of it using the square root, plus or minus square root. And the completed square is the process of to get that square. So x squared minus 7x. What do we need to add to make it a square? So last time we used geometry to do this one. I will say okay, x squared is a square of sine x by x. And then the negative 7x, we can break that in half. Negative 7x x, and that negative 7. The negative 7x is the whole area here. Again, usually area cannot be negative, but bear with me for a moment. Okay, assume that visual line we just use negative 7. So break that in half will be negative 3.5 x and negative 3.5 x. So we break that into 2 and we stack like this. Negative 3.5x, and this is also negative 3.5x. And since this sign is x, this has to be negative 3.5. This has to be negative 3.5. And this is negative 3.5. And to make a complete square, we're going to add that area. And that area is going to be negative 3.5 by negative 3.5. And we do that. Negative 3.5 square. And that is 49/4. It's a fraction. If we want, it's a decimal, 12.25. Let's just use decimal here. 12.25. So that is x, x squared minus 7x. If we add 12.25, we're going to have a square of x minus 3.5 by x minus 3.5. So that is x minus 3.5 square. So with that, we make a square out of this. And to get rid of the square, we use plus or minus square root. But that will come in later. And we have two terms. We determine the third term to make it a square. So that the steps to find the completion square. So Now let's look at the problem. How do we solve for this? First, we see x squared plus 4x plus 5. We only need two terms to make a complete square. So minus 5 on both sides. We have x squared plus 4x equal to negative 5. Alright. So now we will add something to it to make a square. We start from two terms, add something to make a square. Okay. So x squared plus 4x and plus something equal to negative 5 plus something okay. So we make a square for x squared. That is x squared, so x by x area is x squared. Okay. And the 4x you break into two because one piece here and one piece there. The piece here will be 2x and the other piece is also 2x. So this is going to be 2 by x, 2 by x. And with that, we make a square. We need to add something to make a square, and that square will be 2 by 2. It's going to be 4. Right. So 4. So we add 4 on both sides. And so we have x squared plus 4x plus 4 equal to negative 5 plus 4 is negative 1. Now, the left hand side, we have area of the big square will be x plus 2 by x plus 2 or x plus 2 squared. So now we complete the square. Okay. Now with that, we have a square equal to something, and the rule says plus or minus square root will undo a square. Just keep that in mind. We will see this a lot later. So plus or minus square root will undo this square. Now that just becomes just x plus 2. And square of negative 1, we have that at the beginning of the section. Square root of negative 1 is imaginary I. So this is just I. And to get x by itself, subtract 2 on both sides. So we have x equal to negative 2 plus or minus I. Right? So pretty much that. And we can write the solution maybe like this, or if you want to split the solution, negative 2 plus I, negative 2 minus I. And that's what we have. Okay, so only need two terms to complete the square. Once you have the square, use the plus minus square root to get rid of that square. That's the steps. Alright. Now again, only need two terms. Only need two terms. So I will subtract 10 on both sides. and that will give us x squared minus 7x equal to negative 10. Right, two terms. Now we need to add something to make it a square. And we already did this previously. We had 12.25 and the result will be minus 3.5. Okay, so we already did that. 12.25, 12.25. And that will make a square of x minus 3.5 square. And subtract that, you have 2.25. Okay, so, and now to get rid of the square, we will use plus or minus square root. And that's a 3 over 2 or 1.5. Okay, so, and now we just add 3.5 on both sides. And we will have x equal to 3.5 plus or minus 1.5. The plus 3.5 plus 1.5 is 5. And 3.5 minus 1.5 is 2. So if you look at the answer on the previous page, we have the same problem. The solution was 2 and 5, and if we do it this way, it's also 2 and 5. Okay, so that solution by completing square. That look nice, you know, but we're not going to do that because there's a better, slightly better way to do that. So, and that better way is using quadratic formula. And so this is the formula, but we have to memorize it. That's the drawback of the formula. So for the quadratic equation ax squared plus bx plus c equal to 0, the solution is x equal to negative b plus or minus square root of b squared minus 4ac over 2a. And the part that is inside the square root, if it's positive, we have two real solutions. If it is equal to 0, plus or minus square root of 0 will be just 0. So we have one solution. And less than 0, if we have negative inside square root, that is imaginary. So this is nice to know if you can, if you know this. But bottom line is that's the formula. That's all we need really to solve for the equation. Right. So very straightforward. So for this equation, x squared minus 7x plus 10. So a coefficient a is 1, b is negative 7. And c is 10. And quadratic equation x equal to negative b plus or minus square root of b squared minus 4ac over 2a. So b is negative 7, so we have negative 7 plus or minus square root of b square negative 7 square minus 4 ac over 2a. Okay. Negative that positive 7 plus or minus 7 negative 7 square negative times negative 7, that's 49 minus 40, so that is 9 and over 2. So 7 over 2 plus or minus square of 9 over 2. Plus square of 9 is 3. So 7 plus or minus 3 over 2. 7 plus 3 over 2. That 10 over 2 is 5. And 7 minus 3 over 2. 4 over 2 is 2. So once again, we have the same problem of x squared minus 7x plus 10. Solution was 2 and 5, and now it's still 2 and 5. Okay. So very straightforward. So that is the advantage of using quadratic formula. It works all the time. For that, I mean this one. Earlier, if you go to previous page, we have this problem and we cannot factor. This problem cannot be factored. But quadratic formula doesn't matter. The equation is just as long as we apply the formula correctly, it should be fine. Okay, so we have A, B, and C. Solution. Negative b plus or minus square root of b squared minus 4ac over 2a. So minus b plus or minus square root of b squared minus 4ac, and that's what we over 2a. Right, just put all the numbers into that formula. So we have negative 3 plus or minus square root of 3 squared is 9, negative 4 times 1 times negative 5, that's a positive 20, and 9, that's 29 over 2. And 29 is a prime number. It can only divide by 1 and 29. So that's all we have. We stuck with the solution, and this is the solution. Okay, so if we want to write, we can spell it out. Plus minus. So that's what we have. Of course, you MyMathLab, if you type the solution, you can just write plus or minus. They will take the plus or minus too. Okay, so this problem we could not factor earlier, but quadratic formula worked just fine. Now we have this one. Okay, so A is 2, B negative 8, and C is 17. And put in quadratic formula. Negative b plus or minus square root of b squared minus 4ac over 2a. B is negative 8, so negative 8 plus or minus b square negative a square minus 4 a c over 2a. Negative and negative, that's 8 plus or minus square root. Okay, negative a square 64, and that minus, okay, 4 times 2 times 17, 136 over 4, and 64 minus 136, negative 72. Over 4. Okay, now that's why we have to we learn how to simplify that negative inside the square root. That will make it imaginary. And we still have 72 inside. Okay, now we will break 72, do the prime factoring of 72. 2 and 36, 2 and 18, 2 and 9, 3 and 3. So 2, 2, 2, 3, 3. 1, 2, 3. Okay, like that. So 72 is 2 times 2 times 2 times 3 times 3. Now if we have the square root, earlier section we say for every pair of number, we have a pair of 2 here, one of them come out. For every pair of number, one of them come out, and we left with 2 inside the square root. So that is 6 square root of 2. Or 6 square of 2. And we substitute into square of 72. So a plus or minus I 6 square root of 2 over 4. And note that all of them are even. Now we can divide everything by 2. Or I will factor out 2 on the top. And we have 4 plus or minus. Take out 2, we left with the 3i square root of 2. And the 2 and 4 cancel out, we have the problem would be nicer if there's no 2 here. But nevertheless, cancel that, we have 4 plus or minus 3i square root of 2 over 2. Okay, problem would be nicer if there's without the 2, but regardless, that's the solution. Just a formula, so straightforward. Put all the numbers inside it, inside the formula, and we'll go from there. Right. So with that, we go to the next section. Other type of equation. Okay. just want to have that other type of equation. So on this, we first type is the polynomial equation. Section 1.6 is extremely long, and we'll cover in a few days, but a bit tedious too. But after we get after we're done with 1.6, the remaining will be a lot easier until we go to chapter 4 and that pick up again. Bottom line is 1.6 is long and tedious. First, polynomial equation. So polynomial equation is like equation that instead of quadratic, it could have higher degree. So we have a cube or even higher degree. And ideally, we want to move everything on one side, and that equal to 0. And to solve for the quadratic, I mean for anything higher than quadratic, we will use the factoring method. Again, factoring method, we're going to make it equal to 0 and try to factor. And here are some common factor: difference of 2 square, difference of 2 cube, sum of 2 cube. Now focus on these two, the bottom two. Here we look at this side, compare that with this. We have the same sign here, and then this side, it will be opposite to that. Same, opposite. And the last one is always positive. Okay, so we have that. Now how do we solve it? Again, by factoring. Factoring meaning zero product principle, meaning one side is equal to 0. Meaning one side equal to 0. Second, let me check this real quick. Right, so we use zero product principle on this problem, meaning that one side has to be equal to 0. So the first step we do is subtract 81x. So the right hand side is equal to 0. And this look like there's a 3x in common, so we can factor out 3x. So on the factoring, we have 3x to the fourth minus 81x. Okay, try to factor that. 3, I'm just going to spell out the product. 3 times x to the fourth is 3 times 1, 2, 3, 4. And 81 is 3 to the fourth. 1, 2, 3, 4, and then x. Now, what do they have in common? Well, there's a 3 and an x. There are 3 and an x in common. What's left is x times x times x. 3 times 3 times 3, 27. Yeah, so that's how we factor 2 times. Very simple. So I'm just going to leave that. And we said 3x x cubed minus 27 equal to 0. Okay, so that's good. Now, zero product principle says a product is 0, either that is 0 or that is 0. And this divided by 3 on both sides, where x equal to 0. So that's the first solution, x equal to 0. Now we have x cubed minus 27. The 27 we did say earlier is 3 times 3 times 3, so that's 3 cubed. So we can write this as x cubed minus 3 cubed equal to 0. And we're going to use this formula. A cubed minus b cubed is a minus b, a squared plus ab plus b squared. So we can write this as x is equal to a and 3 is equal to b. So this we can write as x minus 3 x squared 3x ab plus b squared equal to 0. Okay, that will be 9. And the zero product principle, again, this is 0 or that is 0. Okay, and plus 3 on both sides, we have x equal to 3, and that is the second solution. Now on this one, we just have to use quadratic formula for it. Uh, 1, 3, and 9, that's A, B, C. So formula first. So you have x. Okay. Minus b plus or minus square root of b squared minus 4 ac over 2a. So that gives us negative 3 plus or minus square root of 9 minus 36, that minus 27 over 2, and that is minus 3 plus or minus, okay, minus square 27. That negative is imaginary square root of 27. Square of 27. 27 is 3 times 9. 9 is 3 times 3. So square root of 27 is square root of 3 times 3 times 3. And we have a pair of 3. That 1 3 come out and 1 3 remain. So this is just plus or minus 3i square root of 3 over 2. And we have 2 more solutions. So 0, 3, and that. Okay, x cubed plus x squared equal to 4x plus 4. Okay, again, factoring method, subtract everything on one side to get 0. So x cubed plus x squared minus 4x minus 4 equal to 0. Okay, now this one a little bit different and the previous one. We have 4 terms, so just group the first 2, group the last 2. Now what the first 2 have in common? If we spell it out like this, x cubed plus x squared. X cubed is x times x times x, and x squared is x times x. Factor out the x times x, which is x squared, common, and we left with an x plus, have to write 1 there. So that's how we factor it. And now we can factor out the negative 4. We have x plus 1 equal to 0. And the x plus 1 and x plus 1 is common. We can factor out x plus 1, and we have x squared equal to 0. Alright, 0 product principle. We say this is 0 and that is 0. So let me write this again. X plus 1 is 0. X squared minus 4 is 0. Minus 1 on both sides. We have x equal to negative 1. And this. Usually for quadratic equation, we use quadratic formula. But this will be easier because we have a square already. Remember, square root properties, right? To get rid of the square, we use plus or minus square root. And that will be 2. Square 4 is 2. So x equal to plus or minus 2. Right, so negative 1 plus or minus 2. If we have previous problem I didn't have space to write, but you can write the solution in the curly bracket like that. Yeah. So that. Next we have the radical equation. Moreover, we just worry on the square root equation. So the equation that have the square root in it. So this equation that have the square root in it. So this is called square root equation. Square root equation. So the equation that have the square root on it. So let's review. What did we have earlier? We say that a plus or minus square root we undo with square. At the same time, if we want to undo the square root, square both sides to undo the square root. So that is the rule. So we did say it, plus or minus square root undo the square. Now square root equation, I'll write this. A square will undo a square root. This will undo a square root. But we must check our answers. When we raise both sides to even power or square both sides, we check our answer. They say, why do we check our answers? Well, so we square both sides, right? Let's say if we have square root of x equal to 3, we square both sides. And we have, and square of x squared is x, and 3 squared is 9. So we have that x equal to 9. We put it back and check that's correct. So square both sides, undo square root. So that's good. Now, this is not good. So we have x equal to negative 3. Now we square both sides. And that gives us x. And negative 3 squared is still 9. Then we said, wait a minute. Square root of 9 is not equal to negative 3. So because when we square both sides, we'll lose the information of the negative sign. And that's why we have to check. When we raise to an even power on both sides, I have to check our answers. So that's a very important rule. Square both sides or raise both sides to an even power. Must check our answers. But in this case, called the square root equation. Square root equation. So the first step is to get the square root by itself. So in this case, I will minus 2 on both sides. We have square root of, I try to write a bit small because this might take a lot of space. Right. So square root by itself. This is called the square root equation. So the first step is to isolate the square root. And now to get rid of the square, like we did with this equation, when we squared, we cancel. So we square both sides. But when we square both sides, we must check our answer. Okay, square both sides. So we'll have a square. The square and the square root cancel out. We just have 2x minus 1 here. This we have x minus 2. We have x minus 2. Square is multiplied by itself. And we multiply it out. X times x, x times negative 2, negative 2 times x, negative 2 times negative 2. So be x squared minus 2x minus 2x minus 2 minus 2 plus 4. And we simplify. X squared minus 2x minus 2x, that minus ax minus 4x, sorry. And now we have quadratic equation. So quadratic, let's move everything on one side and use quadratic formula. So x squared minus 6x plus 5. And we can use quadratic formula. Minus b plus or minus square root of b squared minus 4ac over 2a. So negative b plus or minus b squared minus 4ac over 2a. And that will be 6 plus or minus square root of negative 6 squared is 36. That's 20, so that's 16 over 2. And that gives us 6 plus or minus 4 over 2. 6 plus 4 divided by 2. That 10 over 2 is 5. And 6 minus 4 over 2 is 1. So we have 1 and 5. But we're not done. Remember, because when we square both sides, we have to check our answers. To avoid have something like this. That is not true. So we have x equal to 1 and x equal to 5. We will check how we substitute into the original equation. So when x equal to 1, I'm going to put 1 in for x. Okay, plus 2 equal to, again, put 1 in for x. We're not sure if this is equal or not, so put a question mark there. Okay, now this is square root of 2 minus 1, so square of 1, which is 1 plus 2, and that is not equal to 1, so this is not true. So this doesn't work. X equal to 1 is not a solution. Now we go to x equal to 5, and I put 5 in for x. Minus 1 plus 2 equal to 5. Put 5 for x. We don't know if it is true or not. I put a question mark here. And that's 2 times 5, so square root of 5 minus 1, square root of 9 plus 2. Square of 9 is 3, 3 plus 2 is 5, so that is good. So this solution is good. So this problem only has one solution of 5. The one doesn't work, so that's why we always have to check. Okay, always have to check our answers. Now for this, same thing, get the square root by itself, square both sides. So minus 2x on both sides. We have to isolate, get the square root by itself. Right? Now, we square both sides. When we square both sides, make sure you check the answers at the end. So, isolate for the square root, square both sides. And then check. Right, square cancel square root, we have x plus 2. And this square just multiply by itself. That gives us x plus 2 equals 6 times 6 is 36. 6 times 2x, negative 12x. Negative 12x. Plus 2x, that 4x squared. Okay. Combine like terms. X plus 2 equal to 36 minus 24x plus 4x squared. And we move everything on one side to have a quadratic equation. So 0 equal to 36 minus 2 is 34. Minus 25x plus 4x squared. So we have 4x squared minus 25x plus 34 equal to 0. And we solve for quadratic equations, so quadratic formulas. Right. So negative 25 plus or minus square root of negative 25 squared minus 4ac over 2a. Now we simplify that. I need the calculator. Okay. Minus that 25 plus or minus square root of, okay, let's see, negative 25 squared minus 4 times 34, that's 81. Okay. Over 2 times 4, which is 8. So we have 25 plus or minus 12, 81 is 9 over 8. So 25 plus 9 over 8. 25 plus 9 over 8. We have 34 over 8 reduced to 17 over 4. And 25 minus 9 over 8. 25 minus 9 is 16 over 8 is 2. So we have 2, and this is what, 17 over 4, 4.25. Okay. Now let's check. Remember, we square both sides. We must check our answers. First, I'll check with 2. Square root of 2 for x plus 2 plus 2 times x up 2 is that equal to 6? Well, square of 4 is 2. 2 plus 4 is equal to 6. So yes, that works. Now check for 4.25. Uh, 4.25 plus 2 times 4.25 is that equal to 6? Well, I can tell you that 2 times 4.2, that is 8.5 already. And doesn't matter what this is, it's going to be positive. So that positive 8.5, that's not going to be equal to 6. So we only have one solution, is x equal to 2. Okay, so the square root equation, try to get the square root by itself, and then square both sides. And then check our answers. Okay. Now, on to this equation. So now, what if we have two square root? Well, the rule is still the same. Square undo a square root, then we check. So we try to get one square root by itself and then square both sides, and just keep doing that. Again, this will take a lot of space, so try to write smaller. And now we square both sides and check. So square root of 3x plus 1. Square undo the square root. So the left hand side is simple, 3x plus 1. The right hand side we still have the square root. Multiply it out. 1 times 1 is 1. 1 times square root. Square root times 1. Square root times square root. Meaning multiply by itself. So that will be a square. And a square also undo the square root. So end up with 2x plus 1 equal to 1. That's 2 of this. And then plus x plus 4. Square cancel square root. And now let's combine like terms. 3x plus 1 equal to like terms of 1 plus 4, so that is 5. Plus x plus 2 square root of x plus 4. So square both sides, we still have the square root. That means we repeat this process. Get the square root by itself and then square them. Minus 5 on both sides. Minus x. Give us 2x minus 4. And then 2 square of x plus 4. And get the square root by itself. So divide by 2. Now we isolate for this square root. 2 over 2 is x. 4 divided by 2 is 2. So get the one square root by itself, square, get rid of that square root. Get this square root by itself, square, and we get rid of this square root. So we'll square both sides here. And then of course we check. But we already did, so we don't have to check it 2 times. Okay. Right, x minus 2 square and square root square gets x plus 4. Right, multiply this out. X minus 2 times x minus 2 x plus 4 multiply it out, x times x, x times -2, -2 times x, -2 times -2 is 4. Combine like terms, x squared minus 4x plus 4 equal to x plus 4 minus x on both sides, minus 4 on both sides. We have x squared minus 5x equal to 0. This problem a little bit long, but I'm not going to ask anything that long on the test. That is, I will not ask anything that have 2 square root in the problem. Only have 1. Okay, now factor out x. So if x is 0, or that is 0. So if 0 or 5. Now let's check. For the x equal to 0, three times 0 plus 1 minus 0 plus 4, is that equal to 1? So this is square root of 1, which is 1, minus square root of 4, which is 2, and that is not equal to 1. 1 minus 2 is minus 1. So I have -1 on the left side, so that doesn't work. So 0 doesn't work. Now we check x equal to 5. Five in for x plus 1, 5 plus 4, is that equal to 1? 3 times 5 is 15 plus 1 is 16. Square of 16 is 4. And this is square root of 9. Square of 16 is 4. My square of 9 is 3. 4 minus 3 is equal to 1. So yes. So the solution is 5. So yeah, that's certainly a little long of a problem. However, the idea is still the same. Get the square root by itself, because the square we undo it. If we still have square root, get it by itself, square, and we undo it. At the end, make sure you check the answer. Okay. And I think I will stop here, and then we'll pick it up Monday. At least we have something done this week. Thank you for being here. I will stop the video now.